Okay, so there's 4 electrons there, right? And so what element would that be? What does that describe? What element does that describe? So what has 4 electrons? Beryllium, right?
Yeah.
Okay. So we got beryllium. Beryllium, these two represent, right here, these two represent electrons in the 1s2. The first shell can only hold 2 electrons. It is full. Second shell, the second shell here, can hold S's and P's.
Yeah.
So they can hold 8. Okay? So these 2 electrons here right there, those 2 electrons are the second energy level, the S's. So then it's full. So the S's are full. But the second energy level is not. So first energy level can have an S, and that would be 1 orbital, and that would be 2 electrons. Okay. The second can have S's, which is the above, can have 1 orbital, which is 2 electrons, and it can have P, which is 3 orbitals. Okay, which is a total of 6 electrons. Does that make sense?
Yeah.
Okay. And then we'll go up to D today. So then the third can be S's, P's, and we're just going to copy what we have up above for that. And then D's have 5 orbitals, and that's a total of 10 electrons. So the third level can have 18. Okay. So as we look at our periodic table, how many electrons? So if we look at the periodic table, okay, when we go across the first row, how many elements are in the first row? Across the periodic table? 2. Hydrogen and helium. So there's 2. We go across the second row. How many does that add up to be? 8. Okay? We go across the third row. How many would that be? 8 also. We go across the fourth row. Okay, and we'll just write how many is in here. There's 10 elements across that section. We got 18. We go across fifth row, we have 18. Okay, and that's all the far we'll go. So, if you notice, as you go down the columns, they increase by 8 from helium down to the next element, which is neon. And then neon to argon increases by 8. And then argon to krypton increases by 18. So that kind of has something to do with our orbitals that we've been taking a look at. Okay? So we got beryllium. So we're going to go ahead and continue on and go over to boron. I think boron's the next one, right? Boron element 5?
Yes.
Okay. So we're going to go ahead and do boron with a different color than those that we showed there. So then here's an electron for boron. So then boron is 1s2, 2s2, because really you just rewrite what you have. And then the third one is this red one here. That's going to be in the second energy level, but the S's only have 1 orbital and it's completely filled, so it's going to be which sublevel is going to start filling. the p's. And so that's boron. Make sense?
Yeah.
Okay? Now, if you notice on the periodic table, when I taught this earlier, so this is lithium, beryllium, this is boron, and then we got carbon, is that right?
Yeah.
And then nitrogen, oxygen, fluorine, neon. Okay? If you count across this section right here, those are your P's. So all of these sections across here represent filling P sublevels when you get into these sections. Okay? You're filling P. So these are all the P's. These are all the S's, excluding helium. What's this section right here?
The D's.
These are the D's. Because you remember, the D's can have 5 orbitals. And each of them can hold 2. Each hold 2 electrons. So that's a total of 10. So when you count across this section here, those are your D's. And then down here, once we get into them, which we will, if you count across here, there's 14 elements across that bottom section. And these are the F's when they start filling. But the F's don't come in until way later, after you've done a bunch already. Okay? So, we'll do another one. So now, here's carbon. So carbon is 1s2, 2s2, 2p, and the red ones are the p's. So 2p, 2. Okay?
Okay.
So we're going to skip all the way to fluorine. So then here's fluorine. Okay, so there's fluorine. So we've got our 1s2, the blue ones. We've got 2s2, which is the yellow. And then we've got 2p5. And then when we do neon, neon's 1s2, 2s2, 2p, and you're at the end of the p's. So right here's where we're at. Okay, and so we're into the p's, they're done after that one. So that'd be 2p6. Okay, now what we'll learn in a second is we're not going to continually always to show these electrons here. We're going to assume we know that they're there. And we're not going to show these all the time either. That second level. We're going to assume that we know where they're at. Okay? So we're going to act like we know those electrons and their location so that we don't have to start out at 1s each time. That's way too long of a method. So for example, if we did the next one on your list, which is the third row across starting with sodium. So right here is sodium. What we're going to do is we're going to say, we're going to write neon out. Okay, so we're going to go ahead and write neon. And we're going to put it in brackets. And then we're going to show where those electrons are at. So like before, we had the electrons here for, this would have been neon. This is neon right here. Okay? So it has 2, 4, 6, 8 in that second shell and it's full. So now comes along, that would be sodium. So sodium has 11 electrons and there's sodium. Right?
Yeah.
So then, what would we do for sodium? Well, we know it's in the third level. We know that it has to start with what? S. Because when we look here, here's our S's. We're starting right here. So, and then it would be a 1, right?
Yeah.
Because we're acting like this neon is right here. That's neon. So we say neon, and then we're showing, because in the future we don't care about the central atoms or electrons. We do not care about them because they're not going to be involved in bonding. They're not going to be involved in losing and gaining electrons for the most part. We only concern ourselves with the outermost electrons, and they call those valence electrons. So sodium has 1 valence electron. That's it. Has 1 valence electron. So this is what I'm going to have you do. I'm going to have you go ahead and determine, starting with neon, so neon will be our starting point. I want you to go ahead and give me the electron configuration for sulfur. So I want to know the electron configuration for, we're going to find sulfur. So go ahead and do that with your periodic table, and we'll see if you get it right or not. So we put the electrons in. There are 2, 4, 6 in the third level. So 3s2 takes account of 2 of those electrons. Let's just say that those 2 electrons are right here. Now we've got 4 others in which to account for. The s's are full. They don't have any more orbitals. So then we go 3, and then the p would be the next one. And then so there's 4 of p's. There's 1, 2, 3, 4. So it'd be 3p4. Does that make sense? Okay, now the p's, once they all fill up, then you'll be done. So I'm going to have you do 2 last ones. We're going to do 2 last ones. I'm going to have you do, see if you can do it, do calcium. So we're going to have you do calcium. Okay, and then do I call it the shorthand, but they call it the noble gas configuration. So you'd find the noble gas above calcium, and you would put that in brackets, and then that's your starting point. Calcium 19, right? Element 19? No, element 20. I'm sorry.
20.
Okay, element 20. So we're at element 20. So within this, I'm showing 18 electrons. Now, we said that the first level could hold 2 electrons. Second level could hold 8. Third level, the max is 18. Now we've got 10 in there. Really, we should be able to put 8 more in, right? So here's the deal. Calcium, where you find calcium, calcium is in the S's. So wherever you find calcium, here's calcium. It's an S. And we've already filled up the S's. Okay, we've already filled those S's up on that. So where's the next S's come up? The fourth shell. So here's what happens is on this will be our last one. The S is here. Come in. This is their 4 S's. Now there's D's in here that haven't been filled. But we won't fill those until we get to the D section, which is the middle section. So what happens, these electrons choose to go to the 4s before they go to the 3d. Or the 3ds are filled. So the 4th S's will be filled before the 3d. And the reason why that is the case is 4s is less energy than a 3d. That's the reason. So remember, electrons are lazy and they always go to the lowest energy level. So if you did this right, you would have put in brackets argon, and you would have had 4s2. And that would have been it. Okay? And hopefully you guys remember that from when we did it before. That was the tough part for students to figure out, because you would think in the sequence as you're going through, when you do, if we had neon in there, we go 3s2, 3p6, and the next thing the students would probably want to do is they'd put 3d2. Well, they won't fill the 3ds until after the 4s's are full. So that's why if you started in neon, you go 3s2, 3p6, 4s2. And that's why this is the proper way in which to show calcium. Okay? And then we'll get into those D's a little bit later. So, questions you guys have? Does that match up with what you guys have in the box? It does, doesn't it?
Yes.
Now, what'll happen? There's always exceptions to the rule. So, like if you guys look on your periodic table, and you'll see some that don't make sense compared to the way we're doing it. We'll discuss why that is. But there's some of them that will not come out. In theory, they should come out the way we're doing it, but nature doesn't always go along with the theory perfectly. And so that's why some of them vary. Can you guys see some that vary?
Yeah, I'm looking at the 5th row, like that starts with rubidium.
Yeah.
And when you get into the D's, there's like, it goes from 41 to 42, and then it goes to 44, and only 5s1.
Yeah. Yeah. And then I think like there's one row that's like D5S1. You guys, is there some rows that are D5S1? I
Yeah.
think.
Molly, 42 is 45, 5s1.
Yeah, so is 24. So chromium is 3D, 3D5, 4S1. Molybdenum is that way. But when you get down to tungsten, it's not that way. So there's exceptions to the rule, and we'll talk a little bit about that, but you won't have to know them.